Upon performing our calculations using the virtual routine on projectile motion, we found that the desired angle for our cannon to be built is at approximately 45 degrees. At angles less than 45 degrees, we found that the distance traveled by the projectile, which in our case the Nerf ball, to be less than when the cannon is fired at 45 degrees. At angles greater than 45 degrees, the projectile achieved a greater height, but spent a longer amount of time in the air and ultimately traveled a shorter distance than when fired at 45 degrees. We will attempt to construct our cannon to have the projectile to be fired at an angle of 45 degrees in relation to the starting line, attempting to optimize the distance the projectile travels.
The material we are provided to construct our cannon project are 2 tennis ball cans, 2 tennis ball can lids, 18 inches of duct tape, and 2 milliliters of 99% ethanol. The potential problems we might face include running out of supplies, the placement and the size of our ignition hole, as it could lead to our cannon not firing at all, not enough pressure within our cannon to launch the ball, backdraft, which is also created by there not being enough pressure within our cannon, and the possibility of our cannon not being as rigid as we want it to be. The trigger for our cannon is a reaction that is conducted at the end of our cannon. A combustion reaction takes place when ethanol reacts with oxygen and produces carbon dioxide and water. The carbon dioxide product from the reaction then pushes out the ball placed at the opening of the cannon.
After determining from the virtual routine on projectile motion that we need our cannon's barrel to be at an angle of 45 degrees in order to maximize the distance the Nerf ball travels, we then set about making a rough blueprint. Now, math plays a massive role in the design of our cannon and its eventual success, so it is imperative that our cannon takes advantage of our knowledge of the gas laws, knowledge relating to angles, and information from the virtual routine to build the best possible cannon. In creating our rough blueprint, we initially decided that the barrel of our cannon would be 8.5 inches, the height of the stand under the cannon would be 3 inches, that the ignition hole would not be placed too far forward on the cannon barrel, and that the added factor to make our cannon fire the Nerf ball farther than others' cannons would be a cone-shaped structure on the inside of our cannon barrel with a top with small holes poked to increase the osmotic pressure of the closed system using the properties of effusion through a small hole, therefore making our Nerf ball fire more explosively. After creating our rough blueprint, we then finalized our plans, deciding the length of our barrel would be 7 inches, the height of the stand 3.5 inches, the placement of the cone structure 5.5 inches from the back of the barrel, the placement of the ignition hole 1.5 inches from the back of the barrel, and lastly, use the Pythagorean theorem to determine the length of the back part of the cannon barrel to be 3.89 inches and the length of the forward part to be 3.11 inches. We are ready to begin our construction.